All right, we're going to get into the weeds a little bit on this next part. It's looking at the relations. There's a couple of things. It's looking at the relationship between the slope and the correlation coefficient and how they actually calculate it, one formula that they use to calculate it. And the other thing that we're going to look at is how they determine the line of best fit. And it turns out that the way that they determine the line of best fit is they try to find the minimum, the sum of the squared residual, the minimum number of the sum of the squared residuals. And so I wanted to take you through that here. And just to show you this, I think there'll be a couple of homework exercises where you need to identify this relationship. So let's take a look. And I'm going to do it with the calculator because there's a lot of keystrokes and you can follow with me. I'm going to be using list operations. I'm going to be asking you for help along the way. So if you'll please be ready to respond in the chat. Going back to the chat, Caitlin asked, when do we have to turn in the draft? I would ask a week before, like the 4th of October. Turn it in to me by that time so that I'll have time to look it over, give you some comments so that you can then go back and fix it before the due date on October 11th. All right, so what I've done here is I've taken the table from the top, this table right here, and I've transported it down here. So here's your X, and those values are in L1, and there's your Y, and those values are in L2. Now the Y hat, this next column, this is what we call the predicted value of Y from our regression equation. So there it is right there. And we already calculated this to be negative 0.156 X plus 13.348. So this is the equation that we use to make all those predictions of Y hat in this first row. It's kind of too small to write it in here, but I'll try. Can't really see it that well, but I tried to write the same thing here. Now we're going to put these values in L3. Generally, this is what we're after. We have this line coming in here, and we have these points that some of them fall right on the line, some of them fall off a little bit, but we have this line of best fit. All right, so here's our X value, and this point right here is one of our actual data values. This is an XY. Now, if we take that same X value and we go up to the line of best fit, this is our Y hat equation. That equation will predict the Y value at any point, including this one X. So this point right here has the X coordinate, same X, but the Y coordinate is based on plugging that X value into the line of best fit for a prediction. So this Y coordinate is Y hat. And we're going to get that from the regression equation. Now, this distance from here to here, if you wanted to find that distance, what you could do is you could just take the Y coordinate and subtract Y hat. And this is known as a residual. It's a little vertical distance from the point, the actual data point, down to the line or up to the line. And the way that the best fit line is calculated is what they do is they add all these deviations from the line, 0 there, and maybe this one right here. But they try to find a line for which the sum of all those vertical distances is minimum. And some of these residuals will be negative, some will be positive. The points that fall below the line will have negative residuals, and the points that fall above the line will have positive residuals. So to make them all positive, we do what we did with the standard deviation, and we square those residuals and then add them all together. So I think one of the homework problems is they're going to ask you to find the sum of the squared residuals, because we need to minimize that in order to find the line of best fit. I'm going to go back to the lists, and in L3, I'm going to clear out 3 more lists here, because we're going to use L3, L4, and L5. Now the first thing, this is the trickiest one, because the L3s are going to be all these X values plugged into our regression equation. Now we think they're going to be close to 10.35, but we don't know. So I'm going to be doing this first one by hand. In fact, what I might do is just do it on the home screen so you can see what's working. I'm going to plug 19 into our equation. It's the same thing we did up in part E, but I'm plugging in a different X value, where we plug in a number and we evaluate the Y value, and that's the predicted Y value. So this first one is 10.384. So I'm going to enter 10.384 right there. Now this next one here, Y minus Y hat, you've got the Y value here, Y value there. You've got the Y hat value there. This says to subtract those two. Let's see if we can do that. Y there, Y hat there. Take Y and subtract Y hat. So take this number, 10.35, and subtract the 10.384. And there's the number, negative 0.034. And then finally, we're going to take that number. The only difference between these two columns is we're going to take the number in this column and we're going to square it. So I'm just going to hit the squared key, take that number and squared, and there you have it, 0.001156. Now, we don't want to do this way every single time. So we're going to use the computing power of the graphing calculator. And with just a couple of keystrokes, you can complete this entire table. Here's how it works. Go back to your lists in the stat menu. And the first thing we're going to do is we're going to complete this entire row 3. But this requires us to put in this formula here. So this very important first step that if you don't do it, everything will be wrong from here, is to move your arrow keys so that they're highlighting L3. Whenever you want to give a formula to the calculator, you have to highlight a list name. You can't type a formula down here. It's going to expect numbers down here. Formulas can only be entered in if you have the list highlighted. So move your arrow keys so that L3 is highlighted. Then we're going to enter in our regression equation. Okay, so with L3 highlighted, down in the input row, we're going to enter in our equation here, negative 0.156. Now the calculator doesn't understand X, but what we want to do for each one of these entries here is we want to grab the number from L1. So instead of saying times X, because your calculator will store a value of X and just grab that value, whatever it happens to be, we want to grab the numbers from L1 and then add 13.348 here. So this is what the formula looks like. You should see L3 highlighted, and then you should enter this formula in here. In place of the X, we're going to put L1. If you do this, then it's going to grab the value in L1, which means it's going to grab the X value. Now notice what happens when I hit enter. It completes this entire column. And that entire column are the numbers that you want to enter in here. Notice the first one, 10.384. There it is. We calculated that one by hand. So go ahead and write the rest of these numbers. We're going to put the next row in L4 and the last row in L5. Let's work first on L4. Given the way that the lists correspond to the variables, L3 is Y hat, L2 is Y, L1 is X, what formula would we need to type in to L4? Go ahead and write in the chat what you think the formula is that I have to type in using list names. Okay, good. Yeah, so the Y is L2 and the Y hat is L3. So we want, I'm going to do this and I'm going to make an error. So we want L2, that's second and the number 2, minus second and the number 3. Now, I'm writing everything incorrectly, but it's going to give me an error. And the reason why it's going to give me an error is because I'm here in this spot right here, right? I'm not selecting the list name, but I'm selecting this name right here, this entry here. It's expecting a number here, and I'm going to try to give it a list, and this is what you'll see. It's going to give you a data type error. So I'm going to go to, I'll clear this out. Now I want to go up and highlight L4. So once L4 is highlighted, then we'll do L2 minus L3. L2 minus L3. All right, I'm going to hit enter here. And the one number you should note is the negative 0.034. That's exactly this number here that we calculated earlier. But not only do we have this number, we have all the other numbers that appear in that row. So I'm going to write those down. Notice that some of them are negative and some of them are positive. In fact, if you add all of these together, you're going to get 0. All of these positive and negative numbers, they're going to overall cancel one another out. Okay, the last thing now is, so we don't want to have the sum of the residuals to always be 0, which they will be. So what we do is we square all of those residuals to create all these positive numbers. And so we're going to go over to one more list, L5. Now, what do you think I have to enter in there to get this formula? Go ahead and enter it into the chat. What do I have to type down in here with L5 highlighted to get the numbers that I want in that last row? The numbers in L4 are the Y minus Y hats. What do I do to Y minus Y hats to make it look like this? What's the relationship between L4 and L5? Take the L4 list and then you square it. That's the only difference between these numbers and these numbers. So with L5 highlighted, I'm going to type in second 4 to get L4, and then just hit the squared key right here. So it'll look like that. And then when I square it, it gives me all these numbers. In particular, the one that we calculated here looks like it rounds it on the display. Oops. It rounds it on the display, rounds to that decimal place. But then if you're highlighting that number, you can see the unrounded number here. And that's exactly the thing that we have up here. So go ahead. 1, 2, 3, 4, 3, 6. All right. Some of these are in scientific notation. So 0.1, 2, 3, 4, 8. And the next one is 0.0025. So that one right there looks like 4.8 e negative 4, which is 4.8 times 10 to the negative 4. So for 4.8, we move it over 1, 2, 3, 4 spots and insert zeros accordingly. Scientific notation. All right. And then the next one is 0.00078, 0.00436, 0.00144, and so on. Point 1, 2, 3, 9. 0.1, 2, 3, 3, 2. 0.1, 2, 3, 4, 1, 6. All right, so I chose not to write them in scientific notation. You can see all of those numbers are tiny, and when there's tiny, there's not a lot of deviation from the data points in the line, so you're going to get a very good best fit line. Okay, now what they're going to ask you for here is what is the sum of the squared residuals. So L4 are the residuals, and then the next row, we're squaring those numbers. So the numbers in L5 are the squared residuals. And then they want you to calculate the sum of the squared residuals. All right, so there's a calculator function called sum, and what we want to do is to sum up all the numbers in L5. So that's what we're going to find. This is what you want to appear to your home screen, and then you want to hit enter. Okay, so sum, where do you find it? Well, we're dealing with lists, so it's going to be a list operation. And right above stat here is a menu called list. So what we're going to do is go to second and stat, and together those give you the list menu. All right, so I'll do that, second, stat. And the next thing is you want to scroll over to the menu that says the math menu. And then 3, you can see it there. Option number 5 is sum. And then 4, you type L5 and then enter. Now, yeah, this is a lot of steps, and to figure it out, it might take you some time. And just remember what you're doing here. You're just going to add those numbers up. So what you could do by brute force is just get your calculator and take that number plus this number plus this number plus this, and just add all those numbers together. It'll take you a little bit longer than this one, because if you know how to enter this in, it's pretty quick on your calculator. So second, stat. Go over to the math menu, select number 5, sum, goes to your home screen, and then type in second, oops, what happened there? There it is. Second, and then the number 5. And then hit enter, and you get the sum of the squared residuals add up to 0.012. So in that problem where they ask you for the sum of the squared residuals, this is how you would need to do it. You could do it by brute force. It's just going to take you a lot longer. If you know the calculator functions, it does it pretty quickly for you. Okay, the last thing is they want you to confirm a couple of formulas, and they give you these formulas right here. Now, these are standard deviations. The standard deviation of the y coordinates, the standard deviation of the x coordinates. Standard deviations are always positive. So when you take one positive number and divide by another positive number, you're going to get a positive number. So the slope is the correlation coefficient times this positive number. So if the correlation coefficient is negative, then so will the slope of the regression line. And if the correlation coefficient is positive, then since this other fraction is positive, then the slope will be positive. So there's the relationship that we talked about last time, that the slope of the regression line and the correlation coefficient will have the same sign. But they give you a couple of formulas here to confirm, and so what I want to do is just do an example where we have r in this problem was negative 0.991. We have the a coordinate is actually, if we have y equals a plus bx, kind of the b is the slope this time, then b is negative 0.156, and the a value is the 13.348. The other things we need to confirm this are, we need the mean of the x's and the standard deviation of the x's. We need the mean of the y's and the standard deviation of the y's. Now, we have our x values in L1, we have our y values in L2. So we're going to do stat and then calculate, and we can do one variable statistics. Now, there is another feature here called two variable statistics. So you can either do one variable statistics twice, once for the x coordinates and once for the y coordinates, or this new function that we've never used before, but this is the two variable statistics. I'm just going to go ahead and enter it. And your x list is L1, and your y list is L2. And then hit enter, and it gives you the mean of the x's, 21.5, and then the standard deviation of the x's, going to round to 3 decimal places. But as you scroll down, you'll notice now that it gives you the mean and the standard deviation of the y's. So the mean of the y's is 9.994, and the standard deviation of the y's is 0.275. All right, so I wrote these numbers down just because the calculator calculates them for us. But to confirm these formulas, let's use these numbers right here. And the first formula you can see here is the Y-intercept. And that's equal to A, which is equal to the mean of the Y's minus B times the mean of the X's. So there it is. It's the same formula that appears right here. So if we didn't know the A, and we were working with this here, and the only way that we can calculate the A is if we have, the raw data that we can enter it into L1 and L2. But if we didn't have that, and we just had these summary statistics, and I think this is how they frame the problem in the homework. If we just had these numbers, how would you calculate A and B? We take Y bar, which is 9.994, and subtract the B coordinate, which I don't know yet, times the X coordinate, which is 21.5. So I guess I have to calculate the slope first. And the slope is given by the value B, which is R times the ratio of these standard deviations. We know R is negative 0.991, and then we're going to multiply by the standard deviation of the Y. It's right there, 0.275. And we're going to divide by the standard deviation of the X, 1.748. Now, minus rounding error, this is going to give us our B value. Let me type it in here. Negative 0.1559, or negative 0.156. And that was exactly what our slope was. So they're showing you the relationship between means and standard deviations of the individual data set and the correlation coefficient and how they can be used to calculate the slope and the Y-intercept. Now, when we know that this number is negative 0.156, we can put it in there and then evaluate here, 9.994. A negative and a negative is a positive. We'll cancel one of them out. 0.56 times 21.5. And this is about 13.348. And notice that that's the same value as our Y-intercept up here. Okay, so look for this problem in the homework. They're going to give you the means and the standard deviations of the 2 individual lists, L1 and L2, the X coordinates and Y coordinates, and they'll also give you the correlation coefficient. And then with those 5 numbers, you can calculate the A and the B of your line of best fit. Of course, the easiest way to calculate the A and the B of the line of best fit is if you had all the raw data, all the X's and all of the Y's. And you just put them into your calculator and do linear regression, AX plus B or A plus BX, and the calculator will give you the A and B.